Section 6.7, synthetic division. To divide a polynomial by a binomial of the type x minus a, we can streamline the usual procedure, similar to that of long division in arithmetic, to develop a process called synthetic division. So here we have a trinomial divided by a binomial. It isn't of the form, and for synthetic division, the divisor has to be of the form x minus a. Well, we have a coefficient of 1 on our variable, so that meets the criteria for the x, but we have a plus instead of a minus. We can transform this divisor into an m minus a negative 8 so that it's now of the form of required for synthetic division, x minus something, and our something is a negative 8. Synthetic division then is going to give us our quotient instead of doing the long division, and it starts as the following. In this corner, we put our value of a, which we determined to be negative 8. We then put the coefficients of decreasing powers of our variable adjacent to it, and we always want to put a placeholder or a 0 if we have a missing power. So we have m to the second, m to the first, and m to the 0, which is 1, our constant term. So there are no powers missing here, so we'll take the coefficients of the first, the second, and our constant term, being sure to include the sign of each of the terms. The procedure then for our synthetic division that will result in giving us a quotient to this division of polynomials is to bring the leading coefficient down. So we did nothing with it other than put it below the line. Next is to multiply that number by the value of a. So negative 8 times 2 will give us a negative 16. A negative times a positive is a negative. 2 times 8 is 16. We place it underneath the next coefficient, and we add 11 plus negative 16 gives us a negative 5. We then repeat the process of multiplying that quantity by our a value. A negative times a negative is a positive. 8 times 5 is 40, and place it underneath the next term. We then add negative 40 plus 40 is 0. These numbers form what is called the depressed equation. The depressed equation is 1 degree less than we started out with. We started out with a second degree polynomial. These are the coefficients of one lower degree. In other words, m to the first would be our highest degree term, and this is the coefficient of that. 2 times m, a lower power is just our constant term, or m to the 0, which is negative 5. And this last value is our remainder. Since it's 0, it's telling us we have no remainder. It means that m plus 8, when it was divided into this polynomial, went in evenly, telling us that it's a factor with no remainder. This answer then is the quotient or the solution to our division problem that was a result of our depressed equation using the synthetic division. Let's look at another example. They're asking us to divide these polynomials, and we'll use synthetic division as well. The divisor has to be of the form x minus a. In other words, our variable has to have a coefficient of 1. It does. We have a subtraction, and a is 1/2. If you look at this binomial, sometimes it's helpful just to say the opposite of what appears to be there. So it looks like a negative 1/2. We will put a 1/2 in our corner box. Looking to see if we have, first of all, the polynomial in decreasing powers, and making note if there is a missing power that we put a placeholder. So we have y to the third, the second, the first, and our constant terms. So we aren't missing any, and they are in order. So we'll pull off the coefficient of 6 from the first, 3 for the next, -7, and 1. The procedure then for synthetic division is to bring that leading coefficient down and begin multiplying. 1/2 times 6 is 3. We add, we place that 3 underneath the second coefficient and add. We have a 6 again. 6 times 1/2, or half of 6 is 3. Place it underneath the next coefficient. Add those two values. -7 plus 3 is -4. 1/2 times a -4 is a -2. And when we add these together, we end up with a -1. Next, we have what's known as a depressed equation. We're going to create that equation, which is going to be the quotient or answer to our division problem. It's 1 lower degree than what we started out with. We started out with a 3rd degree equation. This first number is the coefficient of our, or leading coefficient of our depressed equation, which is 1 lower power. So it'll start out with a y to the second, which is 1 lower than we had. Our next coefficient of the next lowest term, we have no variable in the next, -4, and this last value is our remainder. Unlike the last problem, we do not have a 0 here, which tells us that when we divided by y minus 1/2, it didn't go in evenly. It's telling us that it was not a, or is not, a factor of this polynomial. And to express our quotient, or answer to the division problem, we would express it as -1 over, whoops, kind of ran into that, -1 over our divisor of y minus 1/2 would be our remainder.